Hey everybody, this is Larry. This is day 26, I want to say, of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, jump in Discord. Let me know what you think about today's forum. If the volume's a little bit low, I am here in Boulder, Colorado, just visiting a buddy and well doing this Leetcode forum. It's really late. I got delayed on a flight for 6-7 hours. So it took me like about 10, 12, 11 hours, something like that to get here. So I'm very tired and it's very late. So I'm trying to not scream, you know. Hopefully this is okay. You could just raise the volume. Let me know in the comments. But I'm not set up with the Wi-Fi because it got so late. Yeah, and my internet's a little bit slow because I'm running off my hotspot. And I don't want to wake my buddy up to kind of get the Wi-Fi. And also, I'm low on battery. So, there are a lot of... Let's just get this done, shall we? And we'll see what we can do. Maybe there'll be a pause because I have to plug in the power or something. But yeah, today we have 3480. Maximize subarrays after removing one conflicting pair. You're given an integer n, which represents numbers from 1 to n. You have some number of conflicting pairs. Remove exactly one element from conflicting pair. Afterwards, count the number of non-empty subarray of nums, which do not contain both A or B for any remaining conflicting pair. What? Return the maximum number of subarrays possible after removing exactly one conflicting pair. Okay. Honestly, no idea what it's asking, but it is a hard problem, which is kind of annoying because I'm just trying to get out of here. Not gonna lie. Okay. I'm just gonna read through the examples, and my apologies if I'm not, as verbose as I am usually, because I'm trying to not wake people up. They're very kind that I'm staying with them. So, okay, let's see. 1 to n in order. Okay. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, n. Okay. Empty subarray. Both A or B. Okay. So. Okay, and we're trying to maximize. Okay. I think the first thing I want to do is just think about this problem without removing one of them. What does that look like without removing one of them? Right? Let me see. I'm just working out the first example, right? So then now, if we don't remove any of them, well, then we have 1, 2, 1, 3, 2, 3. Oh no, not 2, 3, but 2, 4, and 3, 4. Does that help me at all? N is pretty big, but not big enough that you can have to get some logic. What is okay, that's just no dupes. There could be many conflicting pairs. A number can appear multiple times. Yeah, I'm just thinking through it right now. I'm just playing around with ideas in my head. And then now, if we remove 2, 3, what does that mean? Does that mean we could put numbers? That means for each one that has the number 2. Wait, this is wrong. I misread this. This is a subarray, right? So that means that if we don't remove anything, then we have 1. Well, we have 1. I already messed that up anyway. We have 1, 2. that's it for things of 1. You have 2, that's the thing that goes with 2, and then 3, and then 3, 4, right? So that means there's 5 things. No, I missed one, 6. Can I figure this out with contribution? The idea that it went from 6 to 9. Why does it go from 6 to 9? Well, if we remove the 2 and the 3, then what does this mean? That means that for things that end with 3, previously you cannot go past 2. But now that you can, man, I'm already at 25% battery. I started at 30, so I already killed 5% battery, which is not great. Okay, so that means that if we remove 2, 3, then now for each 3 we can go 2. Right? So these stay the same. This adding the 2 back means that we have for everything that starts at 3. I guess 4. Well, 4 now still has to go to 1, right? I'm trying to. I think so. If we don't remove 1 conflicting pair, I think that's basically the idea, right? I think that's easily doable. In that it's just like I call it a contribution problem because you just look at each number and then you go, okay, if this is the last element in the subarray, how many, like how far you can go to the left basically for this problem, right? And for these parts you can kind of work it out. So I don't think that's that bad. But then now removing 1, what does that mean? My initial idea would be like some sort of DP, kind of like the best answer removing 0 and then best answer removing 1, maybe. Constructed off that. Oh, then actually that's fine then, right? Because what is that removing 1? So the way that I think about this now is with like barriers, if you will. I don't know if that this is a great example for illustration, but let's say you have, let me create a, like if you have, say, I don't know, let's just keep this, I'm not creative with coming up with examples. I could walk through one, but not creative with coming up with them for sure. Let's just get something big, right? Like 1, 5, and then I don't know, 2, 8, right? Those are the pairs. And then basically you have 1, 2, 3, 4, 5, 6, 7, 8, say, right? And then 1. What is 1's contribution? Well, 1 we just say 1 is the last number. How many subarrays in which 1 is the last number, right? Well, the answer is just 1 because you can only go 1 to the left. So this is 1. And then 2, you can go 2 or 2, 1. So there's 2 degrees of freedom, right? So that means that this is going to be 2, right? 3, same thing, 3. And then 4 is 4. I might as well write it out. I don't think I lined it up. But then 5 is interesting because 5, now our left barrier is 1, right? So we have a barrier here. We call it a barrier. I just call it a barrier, right? So then now let's just say this is, maybe I'll use this as a, this is a barrier, simple, right? And now 5 can only go past 4 of them, right? But, and that's if we don't skip or we don't remove any number, right? But of course, we can always just say, well, we remove this pair. If we remove this pair, well actually, let me go for, you could do the DP the other way too, but that's fine. And then 6 is still true, right? 6, you still have the barrier at 1. Oops. Right, so that's 5, 7, ASCII artist art. 7, so that's 6 contribution, right? because 7 goes all the way to 1. But then now when we go to 8, you have another barrier at 2. Maybe I could have done another number, but whatever. So then now the barrier is that 8. There's only 6 contribution. But if we remove one barrier, and in a greedy way, we always want to remove this one, because you remove any other ones, it doesn't change the answer. Then now we can say, if we remove 8, this contributes this contributes 7, right? Because it goes to 1. I'm trying to think real quick. But you can't do it like in a piecemeal kind of way, right? Because if we remove this one, this affects future answer, right? Because let's say there's a 9, so it looks like the barriers look like this. It's gonna be 9, and it's gonna go 7 if we don't remove. But 8 if we remove. But that means that removing this adds 2 contribution, right? 1 to the 8 and 1 to the 9. So there's some, it's not quite easy. I think the idea makes sense to me. Going from 0 to 1 and then try to figure out. And then the question then, right, is now in a reverse or maybe like a double layer contribution kind of way. Like for example, we remove this one, this contributes 3, right? You can see that it contributes 3 before it gets blocked off by another number anyway, right? But if we remove this one, then it contributes 2, well, until the end of the way, or until it gets another barrier. It could be here, say. And it's not just 1 per, right? Because let's say we have something like this now, where the barrier is pretty far. Well, removing this, let's just say this is 10. I don't know what that number is, 7, 6. So then it's like maybe, I don't know, 3 if we don't remove. But then all the way up to 2, so like 8 if we remove, right? Or 9 maybe. But you get the, oh no, 8, because it goes to the 2, right? So that means that this contribution is actually 5 per row. Right? I think we have this idea, and I think that's fine with DP and kind of just calculating. I think this is a good idea. I'm going to start with doing the no removal baseline, right? So what would the no removal look like? And I'm at 20%, so I might have to pause a little bit in a sec. Try to plug it in. Okay, so let's just say we have and then we want to say that's annoying, they're just not equal. That means that, yeah, I mean that's fine, but just have to be careful. And swap them back or sort them back, and then now we want to say, and I just call them barriers, right? So barriers, let's say at B we have to add an A, right? Because then now at location B, like for example, you have 2A. When we see the 8, we have to create a barrier at 2 because we can't go past it, right? So yeah, so something like that. Now we can say like that. Yeah. Is equal to I minus last barrier. But then we update last barrier is equal to max of and then some number a, which is for a in barriers of I, right? Something like this. This is not done, of course. We have to do like this, removing one thing, but I just want to double check by looking. And we can audit what we mean, right? Because here we did this one. I think we said it was 6. This one I didn't really do, but we can run it real quick just to kind of see. Oh, oops. Yeah, so this is 6. As we said, this is the contribution. We drew it out, though I erased it, which is that at 1, it contributes 1, 2, 2, 2, 2, 2, right? And this one, let's see. At 2, we cannot go for 1, yep. At 3, it's fine. It goes all the way to 2, so 3 and 2, or 3 and then 3, 2. At 4 is the same thing, and then 5, it cuts off at 3, so it can only do 5 and then 5, 4. So that's fine, right? But, and we're always undercounting, because if this overcounts, that means that something else went wrong, and we undercount because we didn't remove one element, right? And then now we have to figure out how do we move one element. I think we can just do barrier contribution in that way, right? Something like that, but I don't know quite. It's a little bit wonky, for sure. And the reason is because, like, for example, we don't have it, but the same barrier can be in multiple places, right? What I mean by that is that your input could be like, I don't know, 28, 29, but in this case, oops, if you have a 2-9 pair, removing 1, 2 gives you the other 2, right? So you can't just, you know, index it that way, so you have to be really careful. I guess we just have to keep track of the second biggest, actually. I think that's fine. Yeah, actually, and then we can keep track. I think I want to also just maybe keep an index. I don't know that that's necessary, but I think it just makes it easier for me. Maybe not. I don't know. I don't know. I feel like that it's a little bit clearer to me. And this is true. Then we'll I don't know the right way to sentinel these, but okay, so if A is greater than as barriers of 0, it's just like shift and keep track of the thing, the max and the second max. That's what I'm trying to do here. And then this, just want to double check that this does the same thing as before. Should be like 6, and was it like 9 or something? Yeah. So it seems okay. And then now, oops. So then, yeah, so then now we can say this, right? But then now we move our contribution, right? So if we remove so then gains of last barrier of 1. Basically, we want to keep track of it by index. That's what I'm trying to do here. Let's just do counter. Could probably make it an array, but I'm too lazy. Okay, so we add it by to the delta, so it's going to be last barrier of 0 minus second barrier of 0, right? And then we keep track of the index, and then now total is equal to sum of contributions, and then we just maxed over gains, right? So yeah, maybe. Oops. I still want to print out gains real quick just to kind of see if our I don't know, maybe we're right anyway. Nope. So removing index 0 gives us 3. Oh, I am I think I just missed. I don't know what that returns max. I don't know what max gains return, but definitely not a total is 6. Max gain should be. Am I just not do? I showed the values, but I didn't do max. I didn't do it this way. Whoops. Okay, looks okay. Let's give a YOLO submit. Oh, let's take a. You remove 3 by getting rid of the 2, I think. Oh no, you get rid of the 3 maybe? No, you get rid of the 2. No. You get rid of the 3, so then... Actually, I don't know. Maybe you get rid of the 1? If you get rid of the 1, then now 2, 3, and 4 makes sense. Okay, let's see. YOLO. Yes. This is kind of a hard problem, but the code actually ended up not being super long. Because we did it in 27 lines, but definitely harder than it looks. I think I'm happy that I got it on the first go, and with 13% battery left, so I'm pretty happy about that. What the? Wow, when I didn't even remember this problem from not that long ago. But I'm happy that I learned a lot. Apparently I submitted 29 times and don't remember it. Maybe there's some subconscious thing, or maybe today I just slept a little bit better. I don't know. No, I mean, the idea seems like I want to do something similar. Well, this is the DP that I think I was talking about, and I end up not doing it actually. Wow, that is crazy. I don't know why sometimes I click on this, it goes to the left, sometimes it goes to the right. But, I mean, this idea I did today. And we did do this for kind of keep. I mean, I think I'm doing this similar idea, but definitely the implementation was not very good. My first AC last time was still not very good. As you can see, wow, I definitely did it way complicated. I think it shows, just to show you that, yeah, wow, even like, and this is attempt 25. Because today's part, yeah, I mean, you saw how I did it today, and it was, you know, that's what I mean sometimes by like having a good visualization and ideas. I think this is more similar to today, kind of. But even then, I think this is more closer to the DP idea. I think today, is all contribution. And it wasn't that long ago. This was only like 4 months ago, right? This is all about contribution in the sense that, yeah, I figure out the contribution if we don't remove one, and then we figure out the contribution of removing one by having a different visualization, right? I don't know how I visualized it last time. Maybe I have to check on my old video, but this time you can kind of see, like, when I draw it out and visualize it out, I go, okay, well, this is the gain, and then every time we do it, we just keep track of it in the index kind of way. And keeping track of the index actually made it a lot easier with worrying about, like, because it automatically handles the duplicate case for you, because this is just ends up being 0 if you have duplicate, right? So that's why I did it this way. But yeah, I guess today I'm pretty happy with how this turned out. I wish I was able to be louder and kind of maybe even go into a little bit more detail. I know that I'm a little bit because it's already 1 a.m. here in Colorado, but sorry friends. But yeah, I hope that makes sense still, because basically, yeah, I just think about it in terms of barrier, right? And these conflicting pairs, if you have one of the numbers going from left to right sweeping, then we said you cannot go past that, right? So I hope that the no removing thing makes sense. And then I was like, okay, we remove one, and I just visualize these barriers, and then we move this one, then you just get the gains in between, right? And we move this one, you get the gains in between. And then we just kind of keep track of the index of these, and then just, if we remove this, how much do we get? And then just slowly add them all up, and then we just max it out, and that's it. I mean, I end up spending 26 minutes, which for me is not that long, because I definitely spent longer on harder problems, but it looks like I spent a lot longer last time, and I didn't even get a good understanding of it, because even at the very end, I have 9% battery, sorry friends, but even at the very end, I did not do it cleanly. I think today is the cleanest as I've done, right? Even though I didn't explain too much. I'm gonna stop this video before my battery really dies without me, stopping. So yeah, thanks for watching here in Colorado. Stay good, stay healthy, to good mental health. Oh yeah, the complexity, real quick. I mean, this is all linear, right? We don't have, this is linear, everything is linear. So we don't have anything even log in. So this is linear time, linear space. Okay, I gotta run before my battery dies, and I can, like, it's a mess for me to kind of power it back on. So yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.